Second derivative is when we differentiate 2 times. Example 1. Let's say we have y equal ln x squared plus 1. So dy over dx is the first derivative when we differentiate for the first time. Y is a composite function, so we need to differentiate 2 times. Number 1, differentiate ln, we get 1 over x squared plus 1. And then differentiate x squared plus 1. Differentiate x squared, we get 2x. Differentiate 1, we get 0. So combine these two answers, we get 2x over x squared plus 1. For the second derivative, we will differentiate the answer for the first derivative. So here we have 2x as u and x squared plus 1 as v. We will apply quotient rule. Vu prime minus uv prime over v square. V, take the original equation from the denominator, x squared plus 1, multiply by u prime. Differentiate to x, we get 2. Minus vu prime minus u to x, multiply by v prime, which is differentiate x squared plus 1 over v squared. And then try to expand and simplify the equation, and we get final answer, the second derivative of y, 2 minus 2x squared over x squared plus 1 square. Example 2. Let y equal exponent x squared, and we want to show that 1 over 2 multiplied by d square y over dx squared minus x dy over dx minus y will eventually equal to 0. So from this equation, we must know the values for x, for dy over dx, and d square y over dx square. Y is given as exponent x squared. So now we want to find dy over dx. dy over dx is the first derivative of y. To differentiate exponent x squared, we will apply product rule. So number 1, u exponent, and to differentiate y equal exponent x squared, y equal exponent x squared is composite function. So number 1, we differentiate exponent. Number 2, we differentiate x squared. Differentiate exponent, we get exponent x squared. Differentiate x squared, we get 2x. Combine the answer, we get 2x exponent x squared. To find d square y over dx squared, this is the second derivative of y. So take the answer from first derivative and differentiate once more. Here we have to apply product rule. So we denote 2x as u and exponent x squared as v. We use u v prime plus v u prime. Okay, combine the answer and we get the second derivative. Finally, substitute d square y over dx squared, substitute dy over dx, and substitute y into the equation given. From here, we can expand, simplify, and finally, we get the answer equal to 0. So, we prove the equation as true. One more example, example 3. Given y equal exponent x sin x, we want to evaluate d square y over dx square at the point x equals 0. So, given y equal exponent x sin x, to find the first derivative, we must apply product rule. So, u exponent x and v sin x. We use the formula u v prime plus v u prime, and we get this. Proceed to find the second derivative. Differentiate the answer from first derivative. Here we have uv prime plus, here we have uv plus another uv. So we must apply the product rule 2 times. So uv prime plus vu prime. And then once again, uv prime plus vu prime. Okay, simplify the equation and we get second derivative equal to exponent x cos x. Since we want to evaluate second derivative at the point x equals 0, substitute 0 into the second derivative and we get equal to.